Thanks very much. Hi, everyone. So, as you mentioned, my name's Mark, and I have had a long journey in technology and entrepreneurship. But I'm gonna go right back to way back when I was at school. When I was at school, teachers didn't understand, neuro things like ADD and that type of thing, and so they couldn't understand why I wasn't listening in class. And they would tell my parents, "You must have his ears checked." And they checked me, and I was great. But I couldn't focus in class. I had to do all my homework and all my studying at home by myself without any teachers to assist. But quite early on, I discovered chess. So when I was around 11, 12, I started playing chess quite seriously. And I started playing in tournaments, and I had a bit of success as a kid. And chess maybe helped me because I guess my natural impulse is to think intuitively and not concretely and logically. But my intuition was quite strong, but intuition by itself is never strong enough. And chess taught me to balance the intuitive side with the logical side. And that, doing the chess process during high school allowed me to actually be logical and intuitive at the same time. It helps both sides of your brain actually cooperate, which I think is an important capability for an entrepreneur. And my interest was in creative pursuits. I used to make movies, when I was young, I used to make videos and movies with my classmates and all kinds of things. I wanted to go into film. But my father said, that's all very nice, but you need to have a real career. So he convinced me to go into a career. He said, become a lawyer, become an accountant or something. So I actually started studying accounts. I did a BCom accounts, auditing, tax. Being a creative person, that was quite hard for me. And then in my second degree, I started becoming an auditor. And after about 6 months, I couldn't handle it anymore, and I just gave up. I thought, no, I can't do this. But I found out there was a way to study programming, which I'd done a little bit of basic and stuff. There's a company, it's no longer called the Computer Training Institute. I think they've changed their name now. But I went there, I did the aptitude test, I studied, and I had to start doing basic for about a month. And then I had to choose my next language, and I said, okay, I want to do C. And they said, you can't do C from basic, it's too big a jump. And I said, no, I really want to do C. And they said, fine, you have to get 95% for basic. So I did get 95%. And then I went into C. And after about 2 weeks of learning C, they said, okay, your first project, which is due in 2 weeks, you have to build a basic interpreter. And I thought, wow, that's interesting. And so I built a basic interpreter. I copied a maths interpreter, actually, but I used the same ideas, which is just tokenizing all the words and putting them on a stack and manipulating them. And it was amazing. I thought, wow, I can actually build a language of my own here. And that actually really stuck with me. And because of my creative nature and my less structural nature, I was always interested in breaking the rules. I mean, I didn't even see the rules, to be honest. I just went my own way. And so after that, I played around with programming. I loved it. I loved it far more than accounting. But I do think having the accounting and the technology set the path for me to become a tech entrepreneur. I did, part of my reason for giving up auditing was I tried to close my eyes and imagine myself wearing a suit, going into a company and ticking off inventory. And I just thought, no, I can't do that. But then I started to realize I wasn't employable by anybody, to be honest. I felt very unemployable. I thought I can't imagine going to any company, doing anything. So the only thing left for me was to do my own stuff, which is what I did. So my first startup was actually around the year 2000, just over 2 decades ago. It was nearing the end of the dot-com era. Many of you didn't live through the dot-com era like I did. And it was amazing. We built amazing stuff. We used Java. So Java was starting to get big back in 2000. It was just starting to get fast enough because they had a hotspot compiler which sped it up dramatically. But we invented new ways to build the software. And we use you wouldn't even know it these days, but we use something called XSL. Has anybody ever heard of XSLT or XSL? No. It was a way of taking XML, converting it to something. So we built I built the front ends, taking the XML that my co-founder produced and just converting that into JavaScript and HTML and that type of thing, CSS. And we built an amazing product, actually. But it failed terribly when our investors said, sorry, we're not giving you any more money. And we were like, what? This is such a great product. And they were like, sorry. And so, there were a lot of ups and downs in that. I think I'll move to the next slide. These slides are quite abstract. So this is about the journey of an entrepreneur. You're on a roller coaster. You're looking for the pot of gold at the end of the rainbow. There's storm clouds, there's ravens chasing you. It's never easy. Just one thing on being a chess player was chess is very humbling because you lose a lot. And if you can't come back from the loss, you just can't carry on. And so if you want to win a tournament, you have to come back from the loss. Me and some friends actually became card counters back in the day, playing blackjack. And we learned all the tricks of the trade. We actually made money going to all these casinos. And what I learned about card counting in blackjack was even when you're making money, you're actually losing most of the time. You're only making money because you're hitting it big with doubles and splits and blackjacks. Generally, you're losing. There's a huge ego. I mean, we all have egos, and I still have an ego, but you have to be able to overcome the losses, because when you're an entrepreneur, you are losing most of the time. Every day is like a struggle. Things go wrong. You have to be able to bounce back from that. And so I do thank chess and even the blackjack card counting for that, as well as some of my early experiences. So after that company was shut down, I was quite demoralized for about a month or two, but quite quickly I managed to bounce back. I was invited to join a company called Cycom, which was they distributed mobile devices in towns where people could actually use. They could actually use these mobile devices to make their calls rather than their own phone, because it was so expensive in the old days to use your a prepaid phone. And so we arbitraged the whole system, and it was an incredible success. It just grew dramatically. When I was joining, they were making about 3 million rand a month back in 2002. And it was just growing. And then I helped build them systems. Me and my partner from the previous company, we built them systems where they could grow extraordinarily and scale as a business without having to hire so many people. And that became a trend. We used Java, which was what we used. I used Java for everything until more recently. But in that company, we made enough money to build an investment team, which I was part of. And then, I don't know, has anybody heard of Vinnie Lingham? He's an entrepreneur from South Africa. So Vinnie and I became mates, and I actually invested in Vinnie's first company, which was called Clicks to Customers, or Incubator. And then that was about marketing. It was paid search, mainly Google, paid search. And I joined the company. I helped them build out some tech teams. And I did that kind of from the previous company. I kind of maneuvered my way in. And then building those teams, the one thing that always struck me was there has to be a different way to build software than the way we do. And they needed to build websites all the time. So I decided that I wanted to propose the concept of a drag and drop builder. This is back in 2003-4. And we built a system. It ultimately became known as Yola, but it was originally called Synthesite. And I built that with my same co-founder that I'd worked with all along. And what we did in that was we built a natural language processing system where we had 20 million products. And you can just describe in words what you wanted to get a list of products back from. And it was incredibly powerful. And this is back in 2003-4. But we also built the drag and drop features, all the different ways that you can build out a web page. Ultimately, I wanted to move on to something that I loved, which was chess. And I left the company. I sold my shares in both the incubator and the original company. And I had my first real big success in technology. I made enough money where I could pursue my own dreams and also live and pay back SARS for all the money that I still owed them and stuff. And parents and family. I can't even remember, but I remember that it was always tough. It was very hard. And then I started a company called ChessCube. So ChessCube was an online chess site. And this was back in around 2005-6. Again, we used Java. We built this. But what was interesting about ChessCube was it was a highly reactive, responsive system where you had many different users, different roles, doing different things at the same time, many different games, tournaments, people who were moderators, people who were trainers, people who were players, spectators, all having to do different things within this environment. And so that was my first really big project where we had to have these kind of really responsive, reactive systems. But back in those days, we used XMPP as a protocol to manage this. We took an open source product, we just kind of shoehorned it. After a while, and we were starting to grow really quickly. We were growing at about 3,000 new signups a day for maybe a couple of years. We got to a point where maybe 4 or 5 million people signed up. It was really a success. I was so excited. I thought, wow, this is it. I've made it. I raised money from, by the way, for those of you who don't know how to raise money, in the early period, you raise money from the 3 Fs. Have you heard of this concept before? Friends, family, and fools. So I started with family, then I went to friends, then I went to fools. Eventually, I actually went to Remgro, and they also invested in us. Because I felt, well, with all these people, there must be a way to make serious money out of this. I just wasn't sure what that was. And but so for me, there were technical challenges, then there were business challenges. Initially, it was free. We added like social into it. We added chat into it. We added coins into it. People loved it. I mean, people would come and they would chat with each other. People found each other. They actually were married from meeting in some of these chat rooms. People played. People played for hours at a time. There was a huge retention in the system, but I couldn't get them to pay. And I made a number of mistakes in the marketing along the way. Also, we got to a size where the original XMPP protocol wasn't good enough to actually manage this massive distribution in a reactive system. So we were looking at alternatives. And for the first time, I discovered Erlang, actually. So that was the moment where I discovered Erlang. So in Stellenbosch, there was a company called Mixit who had built a chat platform using Erlang. And I thought, what are we going to do about this? XMPP doesn't seem good enough, but maybe. And Erlang has a product, I think they still have it, called eJabberD, which is like a Jabber-based protocol using Erlang. So I thought, this must be it. I mean, this can handle, because we had like 180,000 active users a month. And some of them were there for hours every day and playing games. It was really huge. So I went to visit Mixit, and they said, no, don't use it. It's really bad. I said, what's bad? Is it Erlang? Is it eJabber? He said, eJabberD. He said, it doesn't really scale enough to what you're going to need. We've had so many problems with it. We've actually written our own thing. So we went back and we wrote our own thing. And I won't bore you with the details, but it was a document model where people would subscribe to these documents. It was kind of early. And then any updates would be broadcast to each person in what was called a room. So we had this idea of rooms. So if you're in a chess room or a chess tournament room or a teaching room, people could actually share these events with each other through this. And it gave me a lot of ideas for the future. I'll just move on to the ChessCube part. But ChessCube got to a point where it was kind of breaking even, but never moving ahead. And I felt disappointed because I just thought, well, we've got millions of people using this. People love it. But other platforms like chess.com were suddenly moving ahead of us. And I just thought, I must have done something wrong in the entrepreneurial voyage. And in hindsight, what I realized is that when you have a free product and a paid product, you need to get product market fit for your free product, but you also need to have product market fit for your paid element as well at the same time, because otherwise you're never going to make it that way. And I have a feeling if I waited, because chess is now incredibly popular in the world, if I waited and nurtured it for many, many years, it would have probably really improved. But we just couldn't do it. And so it was around that time that Vinnie Lingham said, Mark, let's start something new. So I said, fine. And then we discussed things. I flew to Silicon Valley, and we started gyft. So there were 3 of us as co-founders. I was the CTO, co-founder. Vinnie was the CEO and co-founder. And we had a COO, CJ McDonald, who started with us. We built out an application. We built an iOS app initially. We took it to Google Ventures. Within 6 months, they put in, I think it was about $1 million back then. And suddenly the pressure was on for me to leave South Africa with my team and move to America and join them. And what gyft was is it was a gift card distribution platform. Again, we used Java. What was interesting from a technical point of view was it was an incredible rush to take this to market. And I'm sure most of you have heard of TechCrunch Disrupt. So we were invited to present at TechCrunch Disrupt. And we'd only been building this for about 4 months. And the one thing I knew about TechCrunch was that when you go on TechCrunch, people go to your website and it breaks. I mean, I'd been on websites that were at TechCrunch and everything just stops. And we just didn't want to be in that position. And this was gift cards, And so, again, we had to rethink, how do we do this architecture in a way that can actually launch to the world at this really massive velocity event where maybe there could be peaks of 100,000 people coming in an hour kind of thing. And so we came up with a model which at the time was kind of avant-garde, but now is more common. And that was, we thought, okay, well, let's not have a server serving the front end. let's just have HTML pages with JavaScript on S3. At the time, nobody did that. There were cross-domain issues, and there were all kinds of problems that you would have to kind of make it work. But we did that, and so we had a very solid server, and the front end was actually distributed. The web part of the front end, which was the part we thought people would probably explore early, was distributed through S3 and these things, and it just took the strain. There was no issue whatsoever. The distribution of our mobile app was handled by Apple. This was on S3. Our server was solid. We didn't go down at all. There was no problems at all in launching. But again, it gave me interesting thoughts of how our team had done that around building these complex event-driven systems. And we basically grew the company. We got further funding from Ashton Kutcher and one other VC. Yeah, but the pressure was on. I had to move, and I had to convince my wife, by the way, who didn't want to live in America at that point. It was very tough, and I had to convince my team to move as well. But we moved at the end of 2013, first week of 2014. It was tough though. I had to borrow money from my mom just to survive and send the kids to school and do stuff. And I thought that might last 3 or 4 months, but it only lasted about 6 weeks at the most. So I was panicking, and again, I owed SARS a lot of money, I think, at the time. But having moved over there, we actually very quickly sold the company. I brought my entire team over. We sold the company to First Data, which is a large payment processor in America. That now I think they've merged, but they do about $1.5 trillion a year in payment processing. And they needed a gift card arm, so they bought us and a few other gift card companies, which they merged under our brand of Gyft. And I worked for them, and I mentioned before I never got a job, but I did get jobs when people bought our company and I had to go work for them. I never want to diss a company, so I'm just going to put it this way. Working in a large corporate banking environment, it's not for everyone. But what was interesting for me was trying to understand how do they operate, and when we first joined, they were like, okay, you guys have done a nice job, but you can't be on the cloud, obviously. So we said, what do you mean? They said, well, you can't be on Google. You can't be on Gmail. You can't be on Google. You can't be on Amazon. And we were like, but we have to. There's no other way to do this. No, we have our own data centers. We have everything you need. But every time you want to do anything, we'll sign it off for you. And how long does it take? About 6 weeks. So we said, any change we make in the front end, 6 weeks, yes. So, but what was interesting about them was as they were exploring getting into the cloud, they were looking at other technologies to see how they could do it. So they looked at Cloud Foundry. And I actually got involved in the team that was looking at Cloud Foundry. Do you know Cloud Foundry, anyone? Cloud Foundry, I'm sure you do, Kevin. So Cloud Foundry was a way for corporates, enterprise, to get into the cloud. And I found it quite fascinating. It was actually fascinating for me. I stopped doing work in my main day-to-day in Gyft. I actually started focusing more broadly in the company on how do they operate? What are the issues they're having? And once again, I went back to my thinking of the way we build technology with organizations is kind of broken. And having a business and a tech background, I could see there were business thinkers who thought a certain way. There were tech thinkers who think a certain way. They don't think in the same way, and it's actually quite hard to cross them. Even if you want to, even if you can convince them of each other's point of view, it doesn't really make sense. And so for a number of years, I had been thinking. I think it's time to move on to my next slide. I had been thinking that it's time to rethink technology totally. I just didn't feel that the world was going to build software the way they did then forever. At some point, it's going to change, and if we can change it by embracing new technologies, like at the time I was very into blockchain. So blockchain was a key thing for me. AI started becoming a key thing in my thinking. I'd always been interested in machine learning, even around the time that I started my first company. I had done quite a bit around that. But I've been having a lot of strange thoughts. You can see the wizard over there. I've been having thoughts esoterically and intuitively about maybe there's a new way to think about software. And I started thinking about the universe and how is the universe come into being. I'm not going to explain how that works. I'm sure many of you know. But I started thinking about certain structures and maybe certain ways that messaging works in the universe and certain primitive elements in the universe. And then I started looking even more broadly esoterically. And I came up with some ideas of how we could actually build software using some of these primitive elements. And then I started doing more research while I was still at First Data. I met various people in Silicon Valley, and I tried to explain that it's an event-driven system. There's different like spatial elements, sort of like microservices, but not as complex as microservices. There's ways to manage agents, where you have this idea of agents. And an agent could be a human, it could be an AI agent. And the more I spoke to people, I got some incredibly good feedback from people. They said, you should really look at the actor model. I said, oh, what is that? And they told me about it. So I started doing research on the actor model. I was still at First Data. I was doing research on the side. But then I started thinking, yes, this makes more sense. I was looking at lambdas, because lambdas, I think, started picking up around, I can't actually remember the year, 2016, maybe 15. And thinking, well, we can have these new structures with like functions at the end of it, like lambdas. And but very quickly, I thought, okay, I need to actually build a business around this, because it goes back to the path of how do we reinvent software, which is something I've always wanted to do. And so at the end of my time at First Data, I had made some money, paid back SARS again, paid back my mom, I was actually, I mean, it was a good result. We sold the company for about $54 million. And we also had certain upsides as well beyond that. And so I went from struggling to being okay again. But I knew living in Silicon Valley was going to be expensive. And I didn't think I could start this company easily in Silicon Valley. So I thought, okay, let me come back to Cape Town, set up a team. Am I still good on time, by the way? So I set up a team here, a small team, tiny team, just to start building out this concept. And so I formed the initial team in 2017. I moved to South Africa in around mid-2017. And then we started bringing other people into that team. I built an office at my house. And then people started coming to my house to work. Kevin over there in the blue is one of the early people coming in. He was an Elixir expert. By the way, I wasn't sure what this actor model, which actor model I should choose. I didn't know anything about Elixir at that point. I'm not sure Elixir was even that big yet. But I came across Pony, and I came across Akka. I said, no, I don't want to do Java-based stuff. So I said no. Then I came across has anybody heard of Pony? No. So Pony was suddenly, like, everyone was talking about Pony. It was an actor-based model that looked really crazily good, but it was very early. And the more I looked at Pony, I thought, this is the one. But then some of the people I had said, let's not do Pony. Let's look at Elixir. And the one guy said, if you don't do Elixir, I'm actually not going to stay. So I said, fine. So I looked at Elixir, I thought, that's looking interesting. And then we actually went with Elixir as our actor-based model. But then within the Elixir environment, we started building out our primitives. Now, I'm going to just explain what these primitives are very briefly. So our primitives are an agent model. So the agent is one part of it, but then the agent, and an agent is really a user that could be a human, or it could be a pre-programmed system, or it could be an AI agent. But that lives on top of 5 other primitives. And the primitives are the space. A space is, it's like a domain or a microservice. But unlike microservices, which are incredibly complex to manage at scale, especially when you have a lot of them, the space takes care of itself. It's a self-managed space. It does its own infrastructure management, thanks to Kevin and others. And you can pop them up. You can have multiple spaces that interconnect with each other. But a space is like a domain in domain-driven design, where it's focused on a very particular type of operation. And in domain-driven design, there's ubiquitous language, which means it's a piece of a domain that is, the people who work in there know what they're talking about. They share a common language, English language, let's say. And so there was a very strong language element to what a space is about, because you can describe a space. Within the space, another primitive is a concept of a role. So you can have a role, so agents can take on roles within spaces, so they can execute certain interactions inside of the space. And the interaction is really how agents interact with each other through the space. And then those interactions are represented by flows, which are actually processes. And then within the flows, we have steps. And steps is kind of like a lambda. It's a function at the end of this tree of elements. And what our thesis is that you can build any kind of application with these with the agent and the 5 primitives. You can build anything. I know it sounds obscure, and in a way it sounds obvious, because we all know those kind of aspects of building software. But can you build an agent-based model using these? And can you build anything? Can you build like very low-level elements? Can you build very high-level business elements using the same primitives? And the more we played with it, the more the answer was yes, you can. You can build anything with those elements. And it works incredibly well, especially in a functional environment, because you just have a sea of functions that operate, and you can distribute those functions. You can create a node, you can cluster your nodes, you can have them on different machines. And for us, because we were using Elixir and Phoenix, so Elixir and Phoenix were the core of the underlying engine. So we built out our original code of these primitives in Elixir. Over time, as we improved the visualization of our platform, so what we did was, initially there was no visualization, there was just code. Later, we built a way where you could visualize what your code was doing. So it was almost like an IDE, where you could see these different primitives and how they interoperated with each other. And then down the line, we made changes to the visual, where if you tweaked the change in the visual element, it rewrote the Elixir code too. And so doing that, we had a two-way street, where you could just write it in Elixir and see what it did, or you can make changes in the visual. And a lot of our early developers didn't like the idea of using the visual, because they're used to code. And people don't always like the visual, especially if you're a deep-end, back-end, serious, middleware-focused Elixir professional. I'm not pointing any fingers. But suddenly we could do more and more with the visual elements. We could actually create more control over the application. We actually built a debugger. We made it easy to find bugs. We made it easy to extend. And then over time, as we extended these primitives, instead of writing the extensions in code, we actually rewrote the extensions in our visual environment itself. And then it came to a certain point where we actually thought, let's go back in history and rewrite all the original code in Trixta itself, using the visual elements. And that allowed us to create more consistency, so it would be easier for us to extend our platform. I have a feeling I should be on the next slide. No, I won't go there yet. So I'm trying to think where I was. So we ultimately rewrote almost everything in Trixta itself. So Trixta is now written mainly in Trixta. Our core code has been shrinking, and is going to shrink down to almost nothing. It's very meta. I mean, we're building these things which are extensions, and these primitives work on top of each other. And it sounds like it's convoluted, and in traditional programming, that would be you're creating a complex stack where pieces get in. They actually hit against each other and create complexity, and they also create potential stack overflows, maybe. Except this is all just functions. They're all totally independent of each other, all just working away. So we can create incredible concurrent systems using this methodology. We can go across any number of machines and cores, and we can cluster in any way we want to. We can have multiple spaces that interact with each other. And we can describe all of these through the idea of a space, which is like a domain way of thinking. The roles themselves can be described in language or English too. What they do can be described in language. And it went back to our core thinking of around, this is a way to describe things in language. And so we actually we applied for certain patents, and we got a patent about 6 months ago, which we'd applied for, started working on about 4 years back, which is, can you take a language model, take the information coming out of a language model, and then build an architecture straight from that? And the architecture is our kind of architecture. And we actually got that patent in the US. And it's quite an important patent, we feel, because since then, GPT took off. People are now talking about autonomous agents. It's becoming a standard thing. They're talking about the roles that agents can take. They're talking about a series of different agents that interact with each other. And they're actually starting to use the language we use. And now we've gone even deeper into using AI. Gavi at the back there, he's also one of the key people who built a lot of our AI agent elements. And we have a lot of assistance with AI. Am I doing okay on time? Okay, cool. And now what's happening is we're starting to get exponentially faster and faster in building Trixta and applications from Trixta. Because we're using the AI to augment the coding part. And the AI can do a lot. And we're adding more chat elements, and we're building generative chat into our systems. We're actually launching a product in mid-January. Our first project, internally it's codenamed Nexus, where you actually use generative chat to kind of construct these things. But under the hood, it's Phoenix, it's Elixir, and certain functions you can write in code, obviously. But we're also finding that we can write those functions sometimes with code generators from the generative AI world. And so we actually support Python, Rust, and Elixir for these functional elements as well. So I will move on. I will move on to the next part. So where I want to express our deeper thinking is that my view, and this may not be popular here, but I'm going to express it anyway, is that I don't think we're going to think about building software as a separate thing anymore. I think we're moving towards a world where your business and your software are so intrinsically linked that we start thinking about the business. And as we're thinking about the business and expressing what the business is, the software will evolve alongside with it. And if there was a way to write software where you can build it and you can go back and change it anytime you wanted to without any serious legacy problems, then it gets easier to build software that constantly changes in alignment with your business. Your business could have a very specific path, but it could be doing experiments, and you could just and the software is just kind of fleshing itself out along with the business people and the tech people as you go. And so if we rethink what a software developer is, which I know we often don't want to do, I do think Elixir is a good one to hold on to, though, because I think that's the key. So our thinking really is building your business. Originally, they used to say build your software at the speed of ideation, but now it's build your business at the speed of ideas, where you can focus on the why and the what of your business, but Trixta helps you build the how. And it's really, for us, it's very much around AI agents and an agent workforce, which we're looking to actually, we're going to be employing our first AI agents in January. So we have people joining us who are going to be helping us flesh out marketing people. And when I say people, I don't mean humans. But our belief, though, is that humans have a place alongside AI agents. There could be more AI agents than people eventually, because they cost only a few dollars a month. But a human workforce, AI agents, and enhanced humans, where we just get extra support in what we're doing. But what I think it does is, by having business front and center with your technology, you can express your business in ways that is clear to everyone. You can see your software, you can play with the software, you can extend your software. And for us, under the hood, that is Elixir. I'll go on to my last slide, about humans in the future. So I just did this as a joke, actually, a few days ago, because you might see that there is spaghetti all over the floor there. So all those humans are making spaghetti, but our trickster fox over there, he took this spaghetti and he kind of created spaghetti bling around his neck. So it's all under control. There's definitely a space for humans in the future, but I think it's going to change. I think it's not going to be writing like maybe small functions anymore. I think it's really bringing our systems thinking into applications that are going to be much more rich and deep than the ones we've previously had. Because we can create anything, and we can do it faster, and we can make it fit business. I think there's going to be a proliferation of very sophisticated, event-driven distributed systems that even the corner shop's going to have access to, with their own warehousing solutions and distribution and complex, sophisticated payments. And there's just going to be so much coming in this is our thesis, in the next 3 to 5 years, that the role of the developer is going to shift. And just one last point on this is that in Silicon Valley, which I'm now out of for a while, there's been a lot of developers who've lost their jobs in America, like hundreds of thousands. And what I think is going to happen is, and I think it's a bad thing, obviously, but I think there's a shift. I think those people are going to be our next ramp of entrepreneurs coming into the tech space. I do feel that AI is going to have a place with it. I do think Elixir is, for me, that's the ultimate language and environment to build applications in the future. So I'm very pro Elixir. I'm so glad that we didn't go with Pony. I just feel like there's a lot of opportunity in the future. And if anybody wants to reach out to us and come chat about Trixta, we are launching our first product. I was going to briefly explain the first product, just a 1-minute overview. It's an ideation platform where you kind of describe what you want to build in English or any language. And then it starts trying to work with you to figure out what are the different roles and what are the interactions that happen in your application. And very quickly, within minutes or half an hour or so, you can actually construct a clear view of what your application is. Under the hood, we're actually building an application model for you, but we're not going to launch that part soon. Like initially, it's just going to be around just talk about your application, and then we will generate documentation for you that you can take to use to any developer. You can build it yourself, or potentially we could help you build it. Thanks very much, and I'm open to questions.
Yeah, thank you very much, Mark. Any questions for Mark?
Hi, Mark. Thanks for the presentation. Thoroughly riveting. Coming from Java, did you ever consider Clojure to do your next thing?
Yeah, I think we looked at. I think we were at a point where it was too late for us to switch to Clojure. I am an investor in companies as well, and I'm an investor in a company called Cognition, and they use Clojure for their systems. And I've had a lot of chats with them and their architects around Clojure. It's the closest thing I can think of to what we do in a way. So I do think that is a really good system. But I actually didn't go down that path in my own companies. For me, it was Java, Elixir.
Mark, thank you very much for the talk. Really enjoyed it. My question is, with Trixta, is that would you be able to build like a chatbot that maybe structures your divorce proceedings when you?
Sorry, I didn't hear that last part.
So when you are obviously initiating a divorce, right? It calculates all your estates, who owes who. Do you have a prenup? All that. Would that be possible with Trixta?
Yeah.
Asking for a friend.
So in the Trixta world, our main customer. So one thing I didn't mention is Trixta's been in R&D for the last 6 to 7 years, and the way we accomplished that was we had certain key customers that paid us. One of our main customers is a company called Roomy. It used to be called Waitroom. It's a video platform where people can actually have different rooms where they can chat to each other, and there's even chat under the hood inside of that too. Yes, so you can create chat environments, and you can create privacy elements within it as well, very easily. It's built in, basically. You can create different groupings, and you can take people and put them into other groups. So you could have people in a group where everyone can fight and talk. Then you can have a private group where it's just lawyer and one of the fighters. But it's very simple for us to create these different grouping environments. It's pretty trivial.
Cool. Any other questions for Mark? Yeah, that's just for the recording.
Okay.
Yeah.
Cool. I had it written down, but so the past like 5 to 10 years of tech startups have had a very move fast, break things approach to doing things. And while I understand that as a bit of a response to often stifling corporate controls, how do you find the balance so you don't break the wrong things when you're moving fast?
Do you mean within a Trixta environment or as a general rule?
I mean more so for tech startups.
Okay, so there has been a big shift in the world in the last year and a half, but let's just go before that. I think it's very hard to know exactly what you want to build up front. You may know generally what you want to build, but until you hit the end customer and the product market fit, you don't really know what you're building. So if you build too much up front, that's very rigid and fixed, you're actually going to end up being disappointed in yourself later when you need to make changes to what you built. And also early on, how do you know what is important? And the one way to do that is to move quickly. It's just to add pieces, see if it takes, try again. Some legacy gets built, you maybe clean that up. And it's really about finding that product market fit. And with that comes money, investment and actually revenue from the customer. So I do believe you have to break things. Move quickly and break. I think that's a given. You have to move quickly and break things. But you need to move fast enough that you can undo or stop doing or do something else quick enough if you see one of your experiments isn't working well, until you find that product market fit. There is a danger, though, as you kind of alluded to, and that is if you break things that you built, you may create incredible legacy code, and then your systems get like more and more spaghetti. And harder to fix, and the legacy lives with you, and then you're actually undoing your future. So there is a balancing act. I mean, just for your interest in the Trixta world, you can move fast to break things all the time because even if you break them, you can fix them. You can just slot pieces in and out, functions in and out so quickly that you can undo what you did in the past if you're using the Trixta methodology. As Gabby knows back there, he broke something on Friday, I think, but I'm hoping that might take. He generally fixes more than he breaks it, but he noticed something was broken, and now we're just going to slot in some changes to it. I think the future with AI is that it doesn't matter if you have spaghetti code in the end. If the AI is really helping you, and this is a theory that people are starting to put forward now, if you have AI that understands everything, it doesn't matter how badly you built your code. It doesn't matter if you didn't build it in a modular format. It doesn't matter if it's in spaghetti. Because the AI will actually assist you in actually just moving past that. It's a human problem. We humans are in the way of actually building out software. It's because of humans we have to have complex microservices. It's because of humans, and that's like 2 pizza teams. It's because of humans that we need to have Scrum and sprints and all that kind of stuff. If the humans were less directly in the mix, we can do a lot more and have a lot of fluidity, including moving quickly and breaking things.
Cool. Thanks a lot for the questions, and thanks a lot for the talk, Mark.
Thanks very much. Appreciate it.
One more question. Yeah, quickly.
I guess you addressed it a little bit there in that last comment, but I was curious to hear your thoughts on the onion architecture, if that was considered before you settled on agents and all that.
I don't think I know the onion architecture.
As just separating the layers of the application. You've got the core, and then you've got some business logic and the interactions, and you keep all the side effects at the edge and all that.
Okay, yeah. So I mean, early on, I mean, I don't know the name onion. I think I must have heard it before. Yeah, I mean, I do think I think doing it that way is good. I think modularizing and keeping the effects away from the core is really powerful. As soon as the effects are in the core, then you have to break the core every time you want to make a change. But no, I mean, for me, I had the study of these primitives back already in 2011. I was making some experiments. 2016, I started like really doing more kind of research on it. So I never really thought of anything other than those primitives.
Cool. Thank you.
Thanks very much. Thank you.
Cool. Before you leave, please help yourself to some stickers at the back. There's some of these laptop stickers. Take 1, take 2, take 10. Give them to your friends. Put them on your fridge. Do whatever you want. And there's some water at the back. We don't have to rush to get out of here, so hang around and chat with anyone. Take your time. Thanks a lot.
Cool. Thanks, everyone. Cheers.
We're just very Unitel software.
Oh, okay.
I thought that name was
I see. Interesting. Yeah, Barry's.
So he was one of the 2